Alright guys, in this video we're looking at common mistakes we can make with line graphs. Now, when you're drawing a line graph, generally, most of you will know how to plot the line graph and getting the correct trend. And so it will look right, but there's a few little minor mistakes we can make. Here's an example from a student. Now, obviously the standout mistakes that I'm not focusing on in this session, but there's a title missing here, there's an axis title missing there, and an axis title missing there, right? Before we start analyzing this graph, let's see what the question's about. So how does ramp height affect how far a toy car travels? So we're looking at ramp height and distance. Once again, you need to identify your independent and dependent variable before you start graphing. Or the easiest way to do that is start off with identifying your cause and effect. So if you're still struggling with independent dependent, say, what's my cause and what's my effect? Well, my cause is obviously the ramp height, because I'm going to get a ramp and I'm going to keep putting a low ramp, and also a low ramp and a flat ramp, whatever it is. I'm changing my ramp height. So my cause is my ramp height. My effect is obviously going to be the distance traveled, because maybe I'll have a low ramp and it will travel a less distance than a very high ramp, right? So once you've identified cause and effect, it's easy then to just memorize that your cause is always the one you're changing, and that's your independent variable, and your effect is the one you're measuring, and that's your dependent variable, right? And if you think about it logically, what we measure, that key word, what we measure is the data that we're looking for, right? I'm not going to measure my ramp height. It's already given to me. I chose 5, 10, 15, 20, 25, 30. That's my decision. So I chose that variable. So it's not something I'm measuring. All right, let's move along from that. So you've identified your independent dependent variable. That helps us with marking this question. So this student, which I have made up, I made a bunch of mistakes in this one just so you notice. So if you look at this graph, you think, all right, looks great, looks like a line graph. But you really have to get into the nitty-gritty of it. First of all, over here, it's not labeled, but this person has graphed the 40, 60, 80, 120, blah, blah. So it's these numbers for the dependent variable. And we know our dependent variable always has to be on this side. So our dependent variable is on the y-axis, and our independent variable is on the x-axis. So that's our first mistake. So plotting, I'm going to rub that out so we can write them down. So putting your independent variable and your dependent variable on the correct axes. That's the first mistake we make. A lot of people make this mistake. But if you're understanding it logically, you probably won't make this mistake. Now, if I'm marking this and you already made that mistake, I'm going to minus a mark, but I'm going to keep marking as if though this is your graph, right? I'm going to ignore it and move along. Okay, well, let's ignore it and move along. So they already made that mistake. Let's see what other mistakes there are. Let's look at the scaling. So if we look at this one, do they jump up by the correct amounts? Let's see. Okay, 1, 2, 3, 4. The next one, 1, 2, 3, 4. Good job. This person jumped up by the correct amounts. Now let's look at the actual scale they've made. So in that first 4 boxes, they jumped up from 0, which starts off here, to 40. So that's a jump of plus 40. All right. Then they go from 40 to 60. So that's a jump of plus 20. So that can't be right. We can't have 4 boxes representing 40 and also representing 20 at the same time. So obviously that's our second mistake. So making the scale, or our incorrect scaling, right? So incorrect scaling is one of the most common things. So generally it looks right, because from then on they just went up 40, 60, 80, 100, 120. So it does make sense. But your first starting point, and this is where most of the issue happens, from going from 0 to 40, your first starting point also is part of your graph, and it matters a lot. Okay, we've also got over here when we're looking at the origin. So our origin is this, sorry, what's it called? This corner of our graph. It's where everything is 0 most of the time. So in our origin, this person has labeled the 0 over here, but they haven't labeled it down there. So you have to have your 0 on both sides like that. Because sometimes it might not be 0. Sometimes you might want to start off with 40. This person could have actually done that. They could have started off with 40 and they wouldn't have lost this mark. And they would have jumped up by 20 every time. So start off with your 0 on both sides over here. Okay. All right, so they made that mistake. Another problem. So problem with the labeling of the axis, problem with the scaling. Okay. What about on this side? This is not really a problem. This is kind of just a preference, if I'm being honest with you. But it makes your marker's life easier. So here I jumped up by 1, 2, 3, 4, 5. This person put the 5 kind of like in the middle. I'm a bit confused. So whatever you choose to do is fine, but can you put a line for us there? If you put a little line, it's easier for us to then just understand that you're going up to this line specifically. So you're jumping up to 5 every single time, right? The line, or I like to call it the teeth of my graph, are very helpful. So don't forget your teeth of your graph. That's a smiley face. I don't know if it looks very smiley, but anyways. Okay. What else in terms of the graph? There's one last mistake. And our last mistake in this graph depends on the type of graph, right? So in this graph, it's actually correct. I'm going to do something. I'm going to pretend, so I can't actually, I'm going to pretend this is a different type of graph. Oh, sorry, no, that was correct. My bad. Let me explain what's going on. So it has to do with the type of graph. So use the following data to construct a line graph. To know how to draw this, you need to know the difference between a line and a line of best fit graph. So with my line graph, I've got a bunch of dots, right? And I'm going to connect them. There we go. Connect the dots, easy stuff. With my line of best fit, I have a scatter plot, right? It's also a bunch of dots, but I'm not connecting them. I'm drawing a line that goes in the middle and tells me what's my general trend here, right? So with this one, I want to see it go up and down and up, and so I want to see what's actually happening. With this one, I just want a general trend. Generally, is it increasing or is it decreasing, right? So this graph is asking for a line graph. And if it's asking for a line graph, then I have to make sure it's just to connect the dots. So matter of fact, this is incorrect. Drawing that whole line of best fit was incorrect. But let me pretend this person didn't draw a line of best fit. Watch what I'm going to do. Okay, I'm the student again. And here is my dots. I'm going to make up some dots. And I did the right thing. I connected the dots. Okay, maybe not like that. That's a bit ugly. I'm going to do the nice one. So connect like that, connect like that, connect like that. Pretend I'm using a ruler, please. Okay, I connected the dots and I did that. This is another type of line graph. Okay, good job. It's not a line of best fit, so you've actually connected the dots. Now my issue, and a lot of people do this, is what is this? What is that, right? You're assuming that there's data outside of your points. So your first point was over here. Why are you going beneath the point? Who told you what's happening? So you don't have, if you go to my graph, my data over here, I don't have a value for 0, 0. Nowhere. So I can't assume that there's a point over here and connect it to here. Do not assume there's a point at the origin. So this is my origin right here. Do not assume there's a point there. So really what this should have looked like, if I was to fix it for the student, I would remove this part here. And I would remove that part there because it was never part of the graph. And I would stop at my last point. So do not just add an extra line to connect it to the axes. You don't have to do that for your line graph. Okay. However, this is a line graph. Let's just say I was asked to draw a line of best fit graph. That's the one that the student had drawn initially. With my line of best fit, I'm going to do it for you. Pretend some dots here, blah, blah, blah. I've drawn a line right in the center. Now, conversely, I have the same issue now. This is a line of best fit graph. And with the line of best fit graph, I'm trying to see a trend, a general trend. So it doesn't have to be accurate, guys. It's just telling me what trend I have. And line of best fit graphs are very unique because they allow me to do two things. They allow me to interpolate and they allow me to extrapolate. What do these words mean? What that means is, to first start you off, please connect it to the x-axis or connect it to your, it doesn't always have to be the origin, by the way. So for example, this one, I would just connect it like that. Just continue it. Make it a straight line, continue it, right? As long as it's in the middle. So your ruler, you just have to grab the ruler, put it in the middle of your dots and just draw a line. It doesn't matter where it connects. So don't always assume that it has to connect to here, right? If your data is all the way up there, if it's all the way here, just do a line like that. Anyways, going back to that one, make sure with your line of best fit graph, please make sure that it's actually connected to your axes over here and over here. So it continues. The purpose of that being is interpolation, extrapolation. What do these terms mean? Well, with interpolate, say we had data on, I'm just going to make up some points. Let's say this is 10, 20, 30. I don't know. Let's say we knew at 10 it was this point right there. And then I come and say, hey, what do you think 15 would have been? So right in the middle. What do you think 15 would have been? Do I have a point for it? No, I don't have a point. But I can then go to my graph and be like, oh, well, for 15, it would be somewhere around here. And what that means is I think it would be this point right there. Because according to my trend line, my line of best fit, it should be a number like that. So interpolation allows me to guess what would be in the graph, right? That's why interpolate. What would be in the graph? What data would be at that point? And with extrapolation, comes from the word extra, right? You're guessing what would be on the outside. So with these values right there, specifically, I'm looking at the values that are on the outside of the graph. So I'm going to grab a nice funny color to highlight that one. So these values right there, because they're on the outside, they're beyond my points, right? Actually, matter of fact, it's this entire value from beyond my last point. From beyond my points, that's extrapolation. Because I'm looking at what would be my value there? What would be my value if I continued? So let's say, I'm going to give you an example. Let's say I ran and I was measuring my heartbeat over how many seconds I was running. And I only recorded up to 40 minutes, right? That was my last data point. Right here, we can see it up to 40 minutes. Well, with extrapolation, you get a question. And that question tells you, what if you ran for 60 minutes? Do I have data for 60 minutes? No, my whole graph stopped at 40. But I can extrapolate. I can then guess beyond that. And that's why your line of best fit has to go through your axes. It has to go as far as you can. Don't go outside of the graph, yeah? I've seen people do that. Please don't do that. Okay. Beautiful. That's all we got to know for that one.